Good evening. I'd like to talk about solve the quadratic equations by factoring. Let's introduce these two examples in order to understand the subject completely. The first example is to solve the quadratic equations, which is the x squared plus 7x plus 12 is equal to 0 by factoring. First of all, before starting the factoring, the equation should be in its standard form, which is ax squared plus bx plus c equal to 0. So here we have the equation in this form. So the value of a is equal to 1, the value of b is equal to 7, and the value of c is equal to 12. See that there is no common factor between these three terms. So we check for the possibility of factoring this quadratic equation. So here we search for two numbers so that the product of these two numbers is 12, and the two numbers add up to 7. So the two numbers are simply the 4 and the 3. So the two factors for this quadratic equation is x plus 4, and the second factor is x plus 3. Simply you can check for the correctness of your factoring process. Simply you can multiply x by x, so we have x squared, so this is the first term, and we can multiply the plus 4 by plus 3, so the product is plus 12, so this is the third term. And simply you can sum up the two products of 3 times x and the 4 times x, so 3x and 4x is simply 7x. So our factoring process is completely correct. Now, as per the zero multiplication property, if we have two quantities multiplied by each other and the product is 0, simply either the first term is equal to 0 and the first term is the first factor, which is x plus 7 equal to 0, or either the second term, which is the second factor, which is x plus 3 equal to 0, are equal to 0. So now the two new equations are simply a linear equation, so we can simply solve for x from the first linear equation, x plus 4 equal to 7. We can simply add minus 4 to both sides in order to solve for x, so x is equal to minus 4. And for the second equation, x plus 3 equal to 0, we can simply add minus 3 to both sides. So the second solution for x is equal to minus 3. Now simply we can check for the correctness of our two solutions, which are x equal to minus 4 and x is equal to minus 3, by substituting these values in the main quadratic equation. So for the first solution, which is x equal minus 4, x squared minus 4 squared plus 7x plus 7 multiplied by minus 4 plus 12. So the first term is minus 4 squared, so we have 16, plus 4 multiplied by minus 4 is minus 28, plus 12. So 16 plus 12 is equal to 28, so minus 28, so the result is 0. So the first checking is correct. Let's check for the second solution for x, which is minus 3. So x squared minus 3 squared plus 7x, 7 multiplied by minus 3 plus 12. Minus 3 squared is 9. 7 multiplied by minus 3 is minus 21 plus the constant 12. So 9 plus 12 is equal to 21, minus 21 it's equal to 0. So our second solution is completely correct. Let's see this new example. Solve the quadratic equations. equation 4b plus 7b is equal to minus 3 by factoring. First of all, we should put the quadratic equation in its standard form before start the factoring. So if we add plus 3 for both sides, we get 4b squared plus 7b plus 3 equal to 0. So this equation becomes in its standard form. So as you see here, there is no common factor between the three terms. So the value of A is equal to 4, the value of B is equal to 7, and the value of C is equal to 3. So as per the solution for the equation ax squared plus bx plus 3, simply we multiplied A by C. So 4 times 3 is equal to 12. So we search for two numbers so that the products is 12 and the addition of these two numbers is simply plus 7. So the two numbers is simply the 4 and the 3. Now regarding the middle terms, which is the 7b, we split the middle term according to our solution. So 7b is simply equal 4b plus 3b plus 3 equal to 0. As you see here, we don't have again a common factor, but if you check for the first two terms and the last two terms, regarding the first two terms, we have 4b squared plus 4b. There is a common factor which is 4b. And regarding the last two terms, the 3b plus 3, we have another common factor which is the 3. So if we merge the first two terms together, we have a common factor. And if we merge the last two terms, we have another common factor. So for the first two factors, the common factor is 4b. So if we factor out the 4b, the remaining from 4b squared is b, and the remaining from 4b is 1. And for the last two terms, if we factor out the 3, so the remaining from 3b is b, and the remaining from 3 is 1. This is equal to 0. Now we have two terms, and if you see, we have a new common factor, which is simply the b plus 1. So we can factor the b plus 1 as the new common factor. So the remaining from the first term is 4b, and the remaining from the second term is 3. All of these two factors, multiplication is equal to 0. So we have two factors which are the b plus 1, and the second one is 4b plus 3. Of course, you can check for the correctness of your solution by substituting both b and plus 1 on the second term. Again, as per the zero product property, if we have two quantities, the product is equal to 0. So either the first term is equal to 0. So either b plus 1 is equal to 0, or either the second term, which is the 4b plus 3, is equal to 0. So we have here a new two linear equations with one variable, which is the b. So now we can solve for the first linear equation, which is the b plus 1 equal to 0. If we add minus 1 to both sides of the equation, we get the value of b to be minus 1. So this is the first solution for b. And regarding the second solution, the second linear equation is 4b plus 3 is equal to 0. So if we divide the equation by 4, then add the minus 3 over 4 to both sides, we get the value of b to be minus 3 over 4. So we have here two solutions for b. The first one is minus 1, and the second one is minus 3/4. Now we can simply check for these two solutions by substitution in the main equation. This is the main equation. So for the first solution, if we substitute for b equal to -1 on the left side, the result should be -3 as the right side. So let's check for the first solution, which is b equal to -1. So 4b squared plus 7b, 4 multiplied by -1 squared plus 7 multiplied by -1. So the first term, -1 squared is 1, so 4 times 1 is 4. And the second term is plus 4 multiplied by -1, which is -7. So 4 minus 7 is simply equal to -3. So the equation is balanced, so our solution is completely correct. Let's check for the second solution, which is b minus 3/4. So 4b squared plus 7b, we substitute for b minus 3 by 4 squared plus 7b, 7 multiplied by -3 over 4. Minus 3/4 squared is simply 9 over 16, so 4 multiplied by 9 over 16. 7 multiplied by -3 is simply -21 divided by 4. So what we have here, we have two fractions and we have a subtraction, but the denominator are not common. The denominator for the first fraction is 16 and the second denominator is 4. So according to the least common multiples, the least common multiples for 16 and 4 is 16. So the denominator in the first term stay 16, so 4 times 9 is 36. And regarding the second fraction, we multiply it by 4 for both the numerator and denominator in order to reach for the denominator to be 16. So 21 times 4 is 84, and 4 times 4 is equal to 16. Now we have both denominator are common, so simply we can solve for this operation. So 36 minus 84 is -48 divided by 16. So the solution is simply -3. So the second solution is completely correct and the equation is completely balanced after substitution of the solution. That's all about the solving of the quadratic equation by factoring. Thanks a lot. Goodbye.